Why is it so hard to get to Europa, Jupiter's moon? Europa is one of the 4 largest satellites of Jupiter, known as the Galilean Satellites, in honor of its discoverer Galileo Galilei, who discovered them by looking through his telescope in the year 1610. When Galileo discovered these satellites, he did not imagine that 400 years later, enormous water reserves would be discovered in this place. Today, it is known that Europa is one of the bodies with the most significant amount of water in the solar system, and that it could even have all the conditions to host living beings. But if it is such an essential place for the search for extraterrestrial life, why haven't we been able to send a human-crewed spacecraft to explore this frozen world better? Why is it so hard to get to Europa? First approach. On March 2, 1972, the Pioneer 10 space exploration probe was launched from Cape Canaveral. This spacecraft was part of a NASA program that aimed to take advantage of an alignment gap of the outer planets to explore the solar system's gas giant planets. This spacecraft would have many scientific instruments that would be of great importance to know the mysteries hidden in the solar system's outer planets, about which very little was known at the time. Launched with NASA's Atlas Centaur rocket with a high-thrust force, the probe would leave Earth on a fixed course towards Jupiter to use it as a catapult to head for the outer solar system. The Atlas Centaur rocket accelerated the probe for a net interval of 17 minutes, reaching a speed of 51,682 kilometers per hour or 32,114 miles per hour. Several instruments were activated to perform tests as the spacecraft moved through the Van Allen radiation belts. 90 minutes after launch, the spacecraft reached interplanetary space, and 11 hours later it approached the Moon closely, becoming the fastest artificial object at that moment. The initial momentum and planetary alignment that occurred at that time helped the Pioneer probe reach the orbit of Jupiter on December 3, 1973, becoming the first space probe to explore this distant planet. But Pioneer also took advantage of that moment to explore the moon Europa, where for the first time in history we could see that it was a much more complex world than we thought. 2 years later, the Pioneer 11 probe would also get close to Jupiter's moons, capturing new images with better definition. Both probes managed to cover the distance between Earth and Jupiter thanks to the vast initial momentum and the approaching gap that occurs roughly every 13 months between the two planets. Until then, the data sent back by the probes did not yet show that Europa could be an exciting moon, but that changed with the Voyager missions. The Great Find. However, the Pioneer 10 and 11 probes were much more fruitful than initially estimated. The Voyager program would give us the probes that could best reveal the secrets of the Jovian system. In the 1970s, after the apparent success of the Pioneer probes, NASA proceeded to continue the Grand Tour program. The NASA program initially aimed to send 2 sets of robotic probes to all the planets in the outer solar system, i.e. Jupiter, Saturn, Uranus, Neptune, and Pluto, which was still considered a planet at that time. Thanks to this program, the first group of spacecraft would be successfully launched, Pioneer 10 and 11. However, the project's enormous cost of about $1 billion led to its cancellation and replaced by the Mariner program, which later became the Voyager program. These spacecraft would have similar objectives to the Pioneer, with the vast difference being that they would have much more advanced technology, which had been developed thanks to the success of the Pioneer probes. They would also carry more fuel for more observing maneuvers and a longer-lasting battery that would allow them to use much more sophisticated scientific equipment. Voyager 1 was launched on September 5, 1977 from Cape Canaveral and would arrive at Jupiter in January of 1979, while Voyager 2 was launched on August 20, 1977 and would arrive at Jupiter on July 9th of the same year. Both probes would reach Jupiter in 2 years, taking longer than the Pioneer probes because they carried a heavier payload. This is a reminder that every gram taken into space drastically changes travel time. The heavier a spacecraft weighs, the longer it will take to reach its destination. The Voyager probes were the first to take the sharpest images of Jupiter and also the first to provide essential data on the composition and geological structure of Europa, which at that time had already become a place of great scientific interest, as its high albedo indicated that it probably had ice, which was confirmed by the images of the Voyager probes. A new goal. The two groups of probes, Pioneer and Voyager, initially aimed to take advantage of the approaching gap between the gaseous planets to explore them all and, in the process, take advantage of the momentum they would obtain to leave the solar system. But during those trips, images and data from scientific instruments showed that Europa had a much cleaner surface than expected, meaning that it didn't have many impact craters. The only explanation for Europa's lack of impact craters was that some kind of geological activity constantly renewed its surface. And this was something completely new, since until then, no known artificial satellites showed geological activity. These discoveries raised scientific curiosity about the satellite. And thanks to observations from the Hubble Space Telescope, we discovered that Europa had geysers of water gushing near the South Pole. This finding significantly increased interest in Europa, as we had found water somewhere outside of Earth for the first time, and it was within our solar system. The interest in exploring Europa increased, and now the priority of exploration missions was no longer Jupiter. It became the moon Europa, since if there was water under this satellite's icy surface, we would likely find living beings. A very long journey. Thanks to all the discoveries that were made on Jupiter and its moons, NASA decided to send a new mission to explore not only Jupiter, but also its moons. This would be the mission currently studying this planet, the Juno Exploration Probe. This spacecraft was launched in August of 2011 and was supposed to arrive at Jupiter in July of 2016. But why did it take longer than the Voyager and Pioneer probes? The reason is simple: weight. As we mentioned earlier, the heavier a spacecraft weighs, the longer it will take to reach its destination. The reason for this is the fuel that is used to propel them. All space probes carry some fuel to propel themselves in the vacuum of space. But once they reach a certain speed, the engines shut down so that they only continue to move forward thanks to the initial boost. In space, there is no friction, but there is a force that slows them down, the gravitational pull of the sun. That's why a lightweight spacecraft can fire engines at full power and accelerate to overcome the sun's gravitational pull. But a heavier spacecraft will need more momentum, translating into more fuel and heavier weight. Pioneer 10 and 11 probes weighed only 568 pounds or 258 kilograms, while Voyager 1 and 2 probes weighed 1,620 pounds or 735 kilograms and 1,796 pounds or 815 kilograms each. In comparison, the Juno probe weighs 7,991 pounds or 3,625 kilograms. As you can see, the Juno probe weighs much more than the Voyager and Pioneer probes combined. For that reason, although the initial impulse of the Juno probe was more significant, having a greater weight, it took much longer to reach Jupiter, taking approximately 5 years. A human crewed spacecraft would weigh at least 10 times more than the Juno mission, so travel time would also increase. With today's most powerful rockets, a human crewed spacecraft could not acquire a speed large enough to cover the distance between Earth and Jupiter in less than 5 years. The most conservative estimate is that a spacecraft at least 3 times larger than the Apollo spacecraft that took the first astronauts to the moon could cover the distance between Earth and Jupiter, at best, in 8.5 years, just for the one-way trip. This means that a round trip would take 17 years, something that is entirely unfeasible because to be in space for 17 years, astronauts would have to carry a lot of supplies, food, water, and fuel, which would increase the weight of the spacecraft even more, in turn increasing the travel time. The best case scenario. As you can see, a trip to the moon, Europa, would not be accessible with modern technology. To undertake such a long journey, it would be best if astronauts could make brief stops at other places, such as the Moon, Mars, and Ceres, the dwarf planet in the asteroid belt. If in a few years we were able to establish bases on these celestial bodies that are halfway between Earth and Jupiter, astronauts who undertake the journey to explore Europa could make the trip in less time, since they would not have to carry with them all the supplies they will need for the trip. The spacecraft would be much lighter and will be able to travel faster. Suppose that in the future we manage to put a base on the Moon, on Mars, and another on Ceres, with space bases always in orbit around these 3 bodies, with supplies such as food and fuel for travelers heading back to Jupiter's moons. In this scenario, if a spacecraft were to leave Earth-bound for Jupiter, it could only carry the resources to get to each base it encounters. So once it arrives at the Lunar Space Base, it will fill up with fuel to start the engines at full power and get to Mars as quickly as possible. Then on Mars, it will refill the tank to give a new boost that will take it at full speed to Ceres in the asteroid belt. And once there, it will refill the fuel tank to give it the last push that will take it to Europa, Jupiter's moon, in a record time of just 1.5 years. It would be similar to a car that wants to go around the world. It doesn't need to carry all the fuel it needs for the trip. All it has to do is fill up the tank every time it arrives at a gas station. Once in Europa, the astronauts could carry out their activities and stay there for a couple of weeks, then return to the spacecraft and make the same journey, passing Ceres, Mars, and the Moon to finally return to Earth, in a journey that will have only lasted 3 years. Of course, there are a couple of problems with this hypothetical scenario. First, there's no space base on any celestial body other than Earth, and we may have to wait several decades to see something like this. The second problem is that for this plan to work, the Moon, Mars, Ceres, and Jupiter must be aligned, which doesn't always happen. The third problem is that even if this alignment occurs, which is perfectly possible, astronauts can only take advantage of the alignment for the outward journey, not the return journey, since by the time they reach Europa, the planets will no longer be aligned. So they would have to stay in Europa until the lineup is reestablished, which could take several years. As you can see, getting to Europa is not an easy task. Our current technology does not allow us to reach this moon in a reasonable amount of time, and we do not have space bases on other celestial bodies to help us boost the ships during the journey. So until we have all these facilities, we'll probably have to wait many years to see the first human-crewed missions to Europa. Why is it so hard to go to Titan? Titan is the largest moon of Saturn. This natural satellite is of great interest to scientists since it contains chemical compounds that living beings could produce, that is, by extraterrestrials in the form of microbes. But despite our great scientific interest in this planet, only 4 space exploration probes have managed to reach this distant world, and only one has managed to land on its surface. Why haven't we sent out more missions to explore Titan? Is it tough to go to Titan? Come with us to find out. Titan, the giant of Saturn. The largest satellite of Saturn was discovered on March 25, 1655, by astronomer Christian Huygens. At that time, Huygens had no way of determining the size of this natural satellite, but due to its brightness, he estimated that it could be as large as the Moon. Years later, with more advanced telescopes, the diameter of Titan could be precisely measured, revealing that this satellite was bigger than the Moon and even bigger than Mercury. However, until 1979, the only thing that was known about this gigantic satellite was that it was more significant than Mercury and had an intense brightness, but it was not known why. Pioneer 11 exploration probe flew over Titan and sent the first images of this natural satellite. Later, the Voyager 1 and Voyager 2 probes would fly by Saturn in 1980 and 1981, respectively. When the Pioneer 11, Voyager 1, and Voyager 2 spacecraft flew near Titan in the 1980s, they barely captured a few images of this distant world. The main objective of these exploration probes was to capture data from the gas giant planets. Still, NASA engineers concluded that it would be better to take advantage of the fact that the spacecrafts was already close to those moons to bring them closer and take some images of those distant worlds in more detail. That act of curiosity to see what was in that distant world would end up being the beginning of something much bigger. The first spacecraft to fly over Titan was Pioneer 11, taking the first photographs of the satellite, which allowed us to observe a dense, gaseous atmosphere. Thanks to this, the Voyager 1 mission controllers decided that the probe should make a closer approach to this moon, so it was diverted from its initial trajectory to make a closer flyby of Titan at less than 6,500 kilometers. Unfortunately, Voyager 1 had no instrument to penetrate Titan's fog, so data could only be obtained from its upper atmosphere. The information captured by these 3 space exploration probes was initially unimportant. However, years later, thanks to digital processing technology, the images these missions obtained from Titan would be analyzed in detail, discovering impressive things. One of those images was captured by Voyager 1, which, after being analyzed with the orange filter, revealed a substantial dark region on Titan known as Xanadu. The spectral analyses also showed samples of complex chemical compounds such as methane, which indicated that the natural satellite had a dense atmosphere and some chemical elements in a liquid state, possibly water. All this information would be the watershed for the most critical mission ever sent to Saturn. Of course, we are talking about the Cassini-Huygens mission, the mission that revealed the secrets of Titan. The Cassini-Huygens mission was a joint space project of NASA, the European Space Agency ESA, and the Italian Space Agency ASI that aimed to explore the Saturnian system, particularly the planet Saturn and its fascinating moons. This mission represented a milestone in space exploration, providing invaluable information about the composition, atmosphere, and hidden secrets of this distant corner of the solar system. The Cassini probe was launched on October 15, 1997 from Cape Canaveral, Florida. After an interplanetary journey that included flybys of Venus, Earth, and Jupiter to gain gravitational momentum, Cassini finally reached Saturn on July 1, 2004. This journey of nearly 7 years and more than 3.5 billion kilometers was an odyssey of unprecedented space exploration. The Cassini spacecraft was equipped with various advanced scientific instruments, allowing Saturn and its many moons to be studied in detail. However, the crown jewel of the Cassini-Huygens mission was the Huygens probe, designed to descend to the surface of Titan, the largest of Saturn's moons, and study its atmosphere and terrain. The Huygens probe detached from Cassini on December 25, 2004, and descended into Titan's atmosphere on January 14, 2005. Huygens made crucial measurements during its descent and sent data to the Cassini spacecraft, relaying it to Earth. This historic landing on Titan marked the first and only time to date that a probe successfully landed on the surface of an outer solar system moon. One of the Cassini-Huygens mission highlights was the extensive exploration of Titan, Saturn's largest moon and the only celestial body other than Earth in the solar system with a dense, stable atmosphere. The discoveries made on Titan provided unique insight into atmospheric and geological processes unlike anywhere else. Using its specialized instruments, Cassini analyzed Titan's atmosphere, composed mainly of nitrogen, methane, and traces of hydrocarbons. The probe also revealed the presence of extensive organic dunes on Titan's surface, suggesting active geological processes and a complex interaction between the atmosphere and the surface. However, one of the most surprising and significant discoveries of the Cassini-Huygens mission on Titan was the presence of liquid bodies on its surface. Lakes and seas composed mainly of hydrocarbons, such as ethane and methane, were identified. These liquid bodies represented the first direct evidence of stable liquids on a world other than Earth. Additionally, Cassini radars mapped extensive regions on Titan, revealing intriguing geological features such as vast dune fields, mountains, and craters. These discoveries suggested an active and dynamic geological history on Titan, with processes continuously shaping its surface. Another revolutionary discovery confirmed the presence of a meteorological cycle on Titan, with rain and evaporation affecting its atmosphere and surface. Although different in composition from terrestrial rainfall, this phenomena highlighted the complexity of atmospheric processes on this unique moon. On its descent, the Huygens probe also provided crucial data on the composition and structure of Titan's atmosphere. Subsequently, detailed studies of density, temperature, and atmospheric composition revealed essential information about the conditions prevailing on this mysterious moon. Why should we return to Titan? Titan is a very hostile world for life as we know it, especially for humans. Temperatures on Titan are frigid, having an average temperature of minus 290 degrees Fahrenheit. Additionally, the gravity on Titan is much lower than that of Earth. These extreme conditions pose a significant challenge to the existence of life forms based on carbon and water chemistry, similar to those we know on Earth. Additionally, liquid methane and ethane present as lakes and seas on Titan's surface rather than water, suggests that any life form in this environment would have to adapt to widely different chemical compounds from those we know on Earth. Despite these challenging conditions for life as we know it, Some scientists have theorized the possibility of life forms based on different chemistry existing on Titan. It has been proposed that microorganisms that used hydrocarbons instead of water as a solvent could exist, since Titan has an abundance of complex organic compounds in its atmosphere and surface. However, these are theoretical speculations, and there is no concrete evidence for the existence of life on Titan. Titan's dense atmosphere and unique chemical composition create conditions unlike Earth's. Life as we know it depends on a complex network of biochemical interactions, and Titan could hamper these interactions by the lack of liquid water and low temperatures. In other words, although Titan is a hostile world for terrestrial life, it has the conditions to host another type of life different from what we know on Earth, in addition to having many resources that a future human colony could take advantage of. In this sense, is sending a human crewed mission to Titan in the short term feasible? Dragon Mission Fly. Although at present there is no proposal for a human crewed mission whose main objective is to study the Titan satellite, there is an uncrewed mission that has that objective. This is the Dragon Space Mission Fly. This proposed NASA mission is designed to explore Saturn's enigmatic moon Titan fully. As part of NASA's New Frontiers program, Dragonfly's main objective is to study Titan's prebiotic chemistry and potential habitability, considered a unique window into Earth's past and the processes that could have led to the origin of life. What is the most distinctive about Dragonfly is its innovative approach. Instead of moving across Titan's surface like a conventional rover, the mission will use a drone. This drone, powered by helicopter-like rotors, will enable aerial mobility, providing the ability to explore multiple locations of interest on Titan. This unique capability will allow Dragonfly to analyze a variety of environments, from dunes and mountains to the vast seas of liquid hydrocarbons on the moon's surface. Dragonfly's launch date is 2027, and the mission is expected to arrive at Titan in 2034. Once there, the drone will make multiple flights over several years, collecting data and samples from the surface and analyzing the atmosphere and geological characteristics of the moon. Equipped with state-of-the-art scientific instruments, Dragonfly will seek to understand the complexity of organic chemistry on Titan and evaluate whether conditions on this moon could have supported any form of life, even in its distant past. As you can see, even though Titan is a very distant world compared to the Moon or Mars, there is enormous interest on the part of the scientific community to study this natural satellite in more depth, and that is why this project is being proposed to reveal all the secrets of Saturn's largest moon. So, isn't it tough to go to Titan? Difficult or necessary? Sending a mission to Titan is difficult. It's much more challenging than going to Mars or the Moon. Titan orbits Saturn, and this planet is at about 888 million miles, 6 times farther than the average distance from Earth to Mars, about 140 million miles. A mission to Titan takes 6 times longer than a mission to Mars, and the further we want to send a spacecraft, the more expensive it is in terms of budget. For that and many other reasons, it isn't easy to reach Titan, but it is necessary for the progress of humanity. Titan is a world very similar to what Earth was like millions of years ago. It has an enormous amount of natural resources that we can take advantage of, and it has geological and atmospheric characteristics that no other celestial body in the solar system besides Earth has. Studying this world in more depth is essential to understanding all the geological processes that can give rise to life. If we strive to understand better what is happening on Titan, we will also better understand what is happening on our planet. Everything we know about Titan is very recent, so the first missions with robots are planned to explore it in more detail. We still have a long way to go before we can send out manned missions, but at the rate we're going, slowly but surely, Titan may one day be home to a future human colony. Enceladus is one of Saturn's moons. It's not the largest or closest to the planet, but it is one of the most important. The reason is that underneath Enceladus's ice sheet is a massive ocean of water, which could not only be in a liquid state, but could even have all the necessary conditions to support life. However, although this natural satellite is very important for the search for extraterrestrial life, no spacecraft has landed on the surface of this moon so far. So why haven't we sent any space missions to study this enigmatic moon in detail? Is it tough to get to Enceladus? Famed astronomer William Herschel discovered Enceladus on August 28, 1789, while using his new 47-inch 1.2-meter telescope, the largest in the world at that time, at Observatory House in Slough, England. This moon is a relatively small satellite composed of ice and rock. With a diameter of 513 kilometers, it ranks 6th in size, smaller than Titan, Rhea, Iapetus, Dione, and Tethys. Enceladus is 7 times smaller than Earth's moon. That's why its gravity is feeble, and a person standing on the surface of this natural satellite could jump more than 3 meters high without any effort. Like Jupiter's moons, Enceladus is in 2-to-1 orbital resonance with Dione. That means that for every lap that Dione completes around Saturn, Enceladus completes 2. This phenomena of moons in orbital resonance can be observed on both Jupiter and Saturn, and everything seems to indicate that it is a fairly common phenomena in the solar system. Therefore, it is possible that it is also something common in the rest of the universe. First missions. The first spacecraft to take sharp images of Enceladus were the famous Voyager 1 and 2 probes in the 1980s. These 2 spacecraft aimed to study the solar system's outer planets and photograph the planet's moons. One of those natural satellites was Enceladus, which was in the path of the Voyager probes. Thanks to this, they were able to take a series of photos that revealed that this natural satellite was much more interesting than we had imagined. Enceladus cannot be seen clearly from Earth, even with the most powerful telescopes. This is because it reflects too much sunlight, so its surface is not very well lit. Astronomers believe that because Enceladus reflected so much light, it might have had some atmosphere. However, the Voyager probes discovered this satellite was covered in a thick layer of newly formed ice. Images acquired from this distance had inferior spatial resolution, but revealed a highly reflective surface devoid of impact craters. The absence of craters on the surface of Enceladus caught the attention of scientists because giant planets' natural satellites are normally much more prone to meteorite impacts. When a meteorite falls on a celestial body without an atmosphere, such as the Moon, the impact crater that forms remains there for hundreds of millions of years because there is no natural geological process to erase it. For example, many meteorites have fallen on Earth throughout history, the most famous being the Chicxulub meteorite that fell in the Yucatan Peninsula in Mexico and ended the age of the dinosaurs. However, most of the impact craters on Earth are erased by geological forces and erosion caused by the atmosphere. So if a meteorite falls to Earth after several million years, there is no trace of it. But in celestial bodies without atmosphere or geological activity, this does not happen, since there is nothing to erase the crater. It is for that reason that the craters of the Moon are millions of years old and have not been erased until now. The case of Enceladus grew attention because if there weren't many impact craters on its surface, it meant something was erasing them. But what? Geysers off Earth. After the Voyager 1 and 2 spacecraft, scientists had to wait more than 20 years for a new spacecraft to revisit Saturn. Why did so many years pass between the Voyager spacecraft and the Cassini-Huygens mission? The reason is simple. Once the Voyager probe sent back the first images of Enceladus, scientists and astronomers began observing this moon with the most powerful telescopes on Earth, such as the Hubble Space Telescope. Thanks to the combination of the information provided by the Voyager spacecraft and observations from telescopes on Earth, it was determined that Enceladus was a very important body for scientific research, since it seemed to have a tenuous atmosphere that interacted in some way with Saturn's rings. In addition, thanks to the photographs of the Voyagers, scientists knew that something was constantly renewing the surface of Enceladus. With all this in mind, astronomers planned a mission that could provide information that would help us answer all these questions. So for 10 years, the mission that would help us unveil the secrets of Saturn's moons was planned, the Cassini-Huygens mission. The Cassini mission was launched on October 15, 1997 and arrived at Saturn 7 years later in July of 2004. This spacecraft took longer to reach Saturn than the Voyager probes because it was heavier. The heavier a spacecraft is, the more fuel it needs and the longer it takes to travel long distances. The Cassini-Huygens probe was a 2-part spacecraft, the Cassini orbiter on one side and the Huygens lander on the other. Thanks to Cassini, the most important discoveries about Enceladus would be revealed. NASA engineers considered Enceladus to be an extremely important body, so they made the spacecraft get as close as possible to the Moon. In one of its approaches, Cassini managed to take one of the most impressive images that have been taken so far in the entire history of space exploration. This 2005 Cassini image clearly shows what appears to be geysers or jets of water being shot from the surface of Enceladus. This discovery impressed all scientists, as geysers were observed outside of Earth for the first time in history. But observing them on a small moon with no geological activity was extraordinary. This discovery helped solve the mystery of what was constantly renewing Enceladus' surface, but it put new questions on the table, such as how were these vast geysers produced? What force or energy produced them? What was the geysers expelling? Was it water? If so, where did that water come from? Origin of the E-ring. The images of the geysers on Enceladus help answer many questions, one of which was the influence this moon had on the rings. Since the discoveries made by the Voyager probes, it has been known that this moon interacts in some way with Saturn's E-ring. The E-ring is one of Saturn's innermost rings. The interesting thing about this ring is that it is made up of very small ice particles. The sun's radiation sublimates them, and the ring disappears slowly. The problem is that at the rate that the material of this ring evaporates, by this point the ring should have disappeared completely. But it doesn't, as if the particles that made up the ring were constantly renewed in some unknown way. This is where Enceladus comes in. With images of geysers at Enceladus' south pole, scientists were finally able to test one of their theories, that Enceladus is the main source of particles in Saturn's E-ring. Cassini's images reveal that Enceladus is not only very close to the E-ring, but it is also entirely inside it. This means that without Enceladus constantly feeding the flow of materials, Saturn's E-ring would not exist. But back to the initial question, what produces the geysers on Enceladus? Did Enceladus have tectonic activity even though it was so small? The answer will surprise you. An ocean of temperate liquid water. As we mentioned earlier, Enceladus is in orbital resonance with Dione, another moon of Saturn. This synchrony around a planet causes the satellite closest to the planet to experience enormous tidal forces internally caused by the stretching and contraction of the gravitational force of the objects with which it is synchronized. This is what causes the intense volcanic activity of Io, a moon of Jupiter. This moon is in orbital resonance with Europa and Callisto. Because it is synchronized with two other moons and also with its planet, the tidal forces within Io are immense. As its innermost layers heat up, this produces an enormous number of volcanoes. It was previously thought that very small natural satellites like Enceladus could not have this kind of geological activity, as the tidal forces on Enceladus are not as large as they are on Io. However, scientists found that they were wrong and that the tidal forces on Enceladus are enough to produce geysers. But how are they produced? For now, the most widely accepted theory is that the tidal forces produced by Dione and Saturn on Enceladus stretch and contract it, causing its inner rock core to heat up. The heat produced on Enceladus doesn't compare to that produced on Io, but it is enough to warm the ice sheet above the hot rock. This heat melts the ice, turning it into water and then into steam. Then this vapor expands and, due to the high pressures, shoots out towards the surface of Enceladus, giving rise to the geysers that Cassini captured. In the planetary sciences, this process gives rise to something known as cryovolcanoes. These are ice volcanoes that behave very similar to volcanoes on Earth, but with completely different materials. On Earth, volcanoes occur because the planet's internal heat heats the rock until it melts and turns it into lava, which is expelled to the outside. When it cools, it hardens to become rock again. Something very similar happens on Enceladus, but with ice. The ice that forms the outermost layer of Enceladus is heated by tidal forces. It turns into water and then into steam, which is ejected onto the surface. In the same way that lava hardens when it reaches the surface of the Earth, water and vapor from Enceladus turn back to ice when they reach the surface. In cryovolcanoes, water serves as lava, ice as rock, and steam as ash. They're like volcanoes on Earth but made of ice. Did you know that something like that could exist? Does this mean that there is water underneath Enceladus' ice sheet? The answer is yes. The evidence is compelling. Beneath the surface of Enceladus is an ocean of liquid water that is kept at warm temperatures thanks to the warming caused by Saturn's tidal forces. But if there is an ocean of water beneath the surface of Enceladus, could there also be living things swimming in that ocean? Enceladus habitability. For years, scientists wondered if Enceladus's ocean might have the conditions for living things to live inside. Still, they could not know for sure without a sample of water from Enceladus's inner ocean, so they devised a way to obtain it with the help of the Cassini spacecraft. In 2015, the Cassini spacecraft made a close flyby of Enceladus's south pole, flying 30 miles or 48.3 kilometers from the surface and through a plume of smoke from one of the geysers. A mass spectrometer aboard the spacecraft detected molecular hydrogen, H2, from the plume, and after months of analysis, scientists concluded that the hydrogen in the sample was most likely the result of hydrothermal activity beneath Enceladus's surface. If microbes or bacteria were present in Enceladus's inner ocean, they could combine hydrogen with carbon dioxide dissolved in the water to form methane. This chemical reaction is known as methanogenesis, and scientists believe it took place in the early days of Earth's life. Unfortunately for now, there is no way to prove if life exists on Enceladus, and that is why new missions are being planned to explore this fascinating world and reveal once and for all if we are not alone in the universe. Not since the Cassini mission have spacecraft been sent to explore Enceladus because it is a highly distant and cold world. However, there are currently several proposals to return to Enceladus. One of them is the Enceladus Orbolander mission proposed by NASA, which plans to land on the surface of Enceladus to try to obtain ice samples to help us discover if Enceladus has any evidence of life inside. Why is it so difficult to get to Ganymede? In the vastness of the solar system, Ganymede, Jupiter's largest moon, presents itself as an intriguing destination full of possibilities for human exploration. With a size that surpasses even the planet Mercury, this moon offers a unique environment that could unlock fundamental secrets about the solar system's evolution and provide crucial resources for humanity in the future. However, no rover or exploration probe has landed on the surface of Ganymede. If Ganymede is such an important natural satellite, why has a space mission never been sent to explore? Is that perhaps it's tough to get to Ganymede? The largest natural satellite of all. Ganymede, with a diameter of about 5,268 kilometers, is the largest moon in our solar system. This colossus is bigger than Earth's moon and surpasses even the planet Mercury in size, giving it an imposing presence in Jupiter's orbit. Despite being a planetary mass moon, Ganymede has less surface gravity than Mercury, Io, or the Moon due to its lower density than all three. Its geological structure features a fascinating mix of ice and rock, extensive plains, grooves, and ridges, suggesting a somewhat chaotic geological history. When Pioneer and Voyager probes flew by the satellite in the 1970s, they managed to take images that indicated the presence of impact craters and tectonic structures on the surface, indicating that it was a place with enormous geological riches that could help us better understand the formation of natural satellites and the entire solar system. Initially, the Pioneer and Voyager missions did not have the objective of studying Ganymede, since it was not considered an exciting satellite. The objective of these missions was to study the gaseous planets, since at that time very little was known about them. But this changed when scientists analyzed all the data these missions had provided us about Ganymede. The only satellite with a magnetic field. Ganymede hosts a unique magnetic field, the only one among the solar system's moons. This magnetic field, presumably generated by the convection of its metallic ice shell at the core, piques the curiosity of scientists and explorers alike. Previously, it was thought natural satellites could not have magnetic fields because they were not large enough to produce them by electromagnetic induction in their cores. Still, between 1995 and 2000, the Galileo spacecraft made 6 close flybys of Ganymede and discovered that it had a magnetic field independent of the Jovian magnetic field. This discovery caught the attention of astronomers since until then it was not known that a moon could generate a magnetic field like Earth's. Ganymede's magnetic field is unique in that it produces a tiny magnetosphere embedded within Jupiter's magnetosphere. It is a magnetosphere within another magnetosphere, and it is the only moon in the solar system known to possess this characteristic. This implies that Ganymede is protected by 2 magnetospheres, Jupiter's and its own. So the percentages of radiation perceived on its surface are very low, making Ganymede a potentially habitable place. Thanks to these discoveries, astronomers became much more interested in studying this satellite and decided to point the Hubble telescope to observe it in more detail. This act of curiosity revealed to us that a phenomenon occurs on Ganymede that also occurs on Earth that no one expected to find in a natural satellite. Just as on Earth, the interaction between the magnetic field and solar radiation produces auroras. On Ganymede, the interaction between its magnetosphere and the Jovian plasma coming from Jupiter's magnetosphere produces auroras very similar to Earth's auroras. Using the Hubble telescope to observe Ganymede's auroras in more detail, scientists noticed something odd. Normally, the auroras are produced by the interaction between a body's magnetic field and the radiation coming from the interplanetary medium. However, the behavior of auroras can be modified or distorted by other components in the inner layers, such as, for example, some metals discovered in a vast ocean of liquid water could change the shape of auroras, which could be observed from space. Does it mean that Ganymede could have an internal ocean of water not visible from space? This question got NASA engineers to work and prepare a probe that, among many other goals, would try to find out once and for all if Ganymede had water inside. The mission for this purpose would be the Galileo probe, which took off on October 18, 1989, and arrived on Jupiter on December 7, 1995, after a very long journey of 6 years. Previously, other space exploration probes such as Voyager or Pioneer reached Jupiter in less time, but the Galileo probe was much heavier than the previous ones, weighing 5,640 pounds, while the Voyager and Pioneer probes weighed 1,600 and 560 pounds respectively. Being heavier, a spacecraft can choose two alternatives: use more fuel to reach its destination in less time, or take the time it takes at the cost of not wasting the fuel it has. The Galileo probe did not have large reserves of fuel. In fact, no space exploration mission usually carries a lot of fuel, because the more fuel a spacecraft carries, the heavier it will be. The more weight it carries, the more difficult it will be to acquire great speed. The tiny amount of fuel that space missions carry is used to perform redirection maneuvers when they are close to the target. If engineers decide to use that fuel for the spacecraft to reach its destination sooner, once in place, it will not have the fuel to perform maneuvers, so it will be a waste. The largest water reservoir in the solar system. In the 1970s, after information provided by the Voyager and Pioneer probes, NASA scientists first suspected that Ganymede might have a thick ocean between two layers of ice, one on the surface and one beneath the liquid ocean and on top of the rocky mantle. When the Galileo probe arrived at Jupiter and flew by Ganymede, the images revealed something impressive. The satellite's auroras exhibited erratic behavior, identical to that predicted by models in which Ganymede was considered to have an internal ocean. Galileo's observations, combined with images from the Hubble Space Telescope, suggest that beneath the outer layer that covers the entire surface of Ganymede is a large ocean of salt water that affects the satellite's magnetic field, and consequently, its auroras. Subsequently, in an analysis published in 2014, a study of water's thermodynamics and salt's effects was made. The results obtained indicate that Ganymede could have a stack of several ocean layers separated by different ice phases. All of this evidence proves that Ganymede's inner ocean could contain more water than all of Earth's oceans combined, and it could also be the biggest liquid water ocean in the entire solar system. This discovery not only fuels the flames of the search for extraterrestrial life, but also provides an invaluable source of water, an essential resource for sustainable space exploration, and a future colony on Jupiter's largest satellite. Currently, the astronomical community remains skeptical about the possible habitability of Ganymede's inner ocean, with many believing that while the inner ocean could be completely liquid, it would be too salty and cold to support any kind of life form like those on Earth. But other scientists speculate that if different conditions co-occur, Ganymede's inner ocean could be much less cold than previously thought, and then with warmer temperatures, life could emerge. Some of those factors are: the inner core of Ganymede is still found active enough to produce underwater volcanoes. These types of volcanoes exist on Earth. They are a source of heat for the species of underwater animals that inhabit the ocean floor. If such volcanoes also exist on Ganymede, then the areas near the volcano could be hot enough for life to emerge. Another factor that could contribute to the warming of Ganymede's inner ocean is the tidal forces exerted by giant Jupiter. If the gravitational forces that Jupiter exerts on Ganymede stretch and compress the satellite as it completes an orbit, the energy produced by these forces would be so great that it would warm the internal ocean a little, increasing its temperature by several hundred degrees, enough for living beings to live there without freezing to death. Be that as it may, it is currently unclear whether Ganymede's inner ocean is habitable, so the only way to find out will be to send a more specialized mission to explore it from the surface. A future of Ganymede for humanity. Currently, there is no space mission studying Ganymede, and it is not because getting to Ganymede is very difficult. Sending a spacecraft to Jupiter is difficult, but we've already done it. We don't have a spacecraft orbiting Ganymede yet because everything we know about this satellite is relatively recent. The missions planned decades ago were aimed at studying the planets, not the satellites of those planets. The Juno space mission currently orbiting Jupiter manages to capture some images of Ganymede when it is close to the satellite, providing valuable information about its poles and surface. But as of this video's creation date, no space mission has been put into orbit around Ganymede, much less has there been one that has landed on its surface. The first mission to orbit Ganymede is expected to be the Jupiter Icy Moons Explorer Space Mission, or JUICE mission for its acronym. JUICE was launched on April 14, 2023 from the French Guiana Space Center by the European Space Agency ESA. The JUICE mission is scheduled to make its first flyby of Ganymede in 2031 and then enter the Moon's orbit in 2032, meaning that the JUICE mission will reach its destination 9 years after its launch. The reason? This spacecraft is one of the heaviest ever sent for the study of planets, weighing in at 6,070 kilograms or 13,380 pounds. Weighing so much, the mission must opt for a slower journey, consisting of more than 10 gravity assist maneuvers using Earth, Venus, Jupiter, and some of Jupiter's moons such as Callisto and Europa. The mission aims to thoroughly study the Ganymede satellite and assess its potential to host life. Scientists now know that there is an ocean beneath the surface of Ganymede, and this mission will help us better understand the structure of the ocean, what temperatures it might have, what compounds it has, and most importantly, whether the internal ocean is habitable. When the JUICE spacecraft consumes all its fuel, it will be redirected to impact directly on the surface of Ganymede in February 2034. This maneuver will be similar to the one performed with the Cassini probe when it was slammed into Saturn once it ran out of fuel. This is done to study celestial bodies until the last second. Also impacting the JUICE probe against Ganymede could help us better understand how its layers and tenuous atmosphere are formed. As you can see throughout history, since we began to study the outer solar system and Jupiter's moons, we have been learning new things, and there is more and more interest in understanding what is in these planet-sized satellites. But now, space agencies still have difficulty reaching these places so far from Earth. Why is it so difficult to get to Callisto? In the vast cosmos that stretches beyond our planet, Callisto, Jupiter's second-largest moon, presents a fascinating destination for human exploration. From an internal ocean beneath its surface to a size that borders on the planetary scale, Callisto is an icy, distant world that could represent the next place we look for extraterrestrial life and perhaps a future colony of humanity. If Callisto is such an essential place for the human race, why haven't we sent rovers to explore its surface as we have on Mars? Perhaps it's tough to get to Callisto? Callisto is Jupiter's second-largest moon after Ganymede and the third-largest moon in the solar system after Ganymede and Titan. Callisto has a diameter of about 4,800 kilometers, almost as large as Mercury. Still, despite its size, it only has a third of the mass of Mercury, so its gravity is small in comparison. This is because Mercury has a massive iron core, while Callisto also has metal in its core, but in a smaller proportion. A satellite with a lot of history. Callisto's ancient surface is one of the most cratered in the solar system. The density of the craters is close to saturation. Any new crater will tend to erase an older one. It's like a minefield full of impact craters. Large-scale geology is relatively simple. Callisto has no large mountains, volcanoes, or other technological structures. Impact craters and multi-ring structures, along with fractures and scarps, are the only prominent features found on the surface. The fact that the impact craters on the surface of Callisto remain intact means that this satellite lacks geological activity or an atmosphere that produces erosion. So for a long time, it was thought that Callisto was a wasteland without life or anything interesting to offer. But this changed with the era of space exploration missions. When the Voyager probes flew close to Jupiter in the 1970s and 80s, they managed to capture images from this satellite and found something interesting on the surface of Callisto. Among all the craters on this natural satellite, one called Valhalla stands out. This is the biggest multi-ring impact crater in the solar system. It consists of a bright central region 360 kilometers wide, an inner ridge, and a depression zone with fantastic concentric rings that extend to approximately 1,900 kilometers from the center. This was the crater that Voyager probes managed to photograph, and as soon as the images reached NASA's scientists, it was striking that such a significant impact crater could remain so well preserved. The multi-ring structure of Valhalla crater was likely the result of a giant impact, which pierced the Moon's outer lithosphere and entered the underlying layer consisting of a much softer material. According to estimates, everything seems to indicate that the impact that produced this crater occurred approximately 4 billion years ago. That is, almost the age of the Earth. How can it be that it has remained intact for so long? The reason is that in the solar system, those celestial bodies that do not have geology or atmosphere preserve what happens on their surfaces for longer. An example of this is our natural satellite, the Moon. Since it doesn't have an atmosphere that erodes the soil like Earth does, everything that happens on the surface of the Moon stays there forever. That's why the astronauts' footprints who went to the Moon are still there and will remain there for thousands of years until some meteorite impact erases them. The impact that caused Valhalla crater occurred billions of years ago. Still, because there's no erosion or geological activity, this crater has remained intact ever since, making it a time capsule that will allow us to understand better how the solar system formed. An ocean of possibilities. The first space probes to visit Callisto were Pioneer 10 and Pioneer 11, which passed close to Jupiter in the early 70s. Still, since very little was known about Callisto, both spacecraft passed by and captured little information about the satellite as they did not consider it a priority. The real breakthrough in Callisto's information came later with the flybys of Voyager 1 and Voyager 2 in 1979. These two spacecrafts took images of more than half of Callisto's surface with a 1 to 2 kilometer resolution and accurately measured its temperature, mass, and shape. This data provided us with the first views of Callisto, and then scientists became more interested in the satellite. Subsequently, between 1994 and 2003, the Galileo spacecraft had 8 close encounters with Callisto, taking photographs of its surface at a distance of only 138 kilometers and obtaining the sharpest images of Callisto up to that time. The Galileo orbiter completed global imaging of Callisto's surface and delivered several images with a resolution of up to 15 meters. In 2000, the Cassini spacecraft acquired high-quality infrared spectra from Galilean satellites, including Callisto, en route to Saturn. Later, in February and March of 2007, the New Horizons probe on its way to Pluto obtained new images and spectra of Callisto. In recent years, NASA's Juno mission, designed to study Jupiter and its moons, has continued to shed light on the mysteries of Callisto. Equipped with state-of-the-art instruments, the Juno probe has mapped the topography and composition of the moon of Jupiter, providing essential information for future exploration missions. Thanks to all the space missions that obtained information about Callisto, scientists discovered that this satellite responds to Jupiter's variable background magnetic field, as it is a perfectly conductive sphere. That is, the field cannot penetrate inside Callisto, which could mean that there is a layer of highly conductive fluid inside with a thickness of at least 10 kilometers. What fluid could cause this behavior? You guessed it, water. Well, more specifically, salt water. As you heard, did you think Europa was the only moon with water? Well, it turns out that no, Callisto also has water, and in a large quantity. An internal ocean in Callisto is more likely if the water contains a small amount of ammonia or other antifreeze. In this case, the layer of water plus ice beneath the surface of Callisto could be between 250 and 300 kilometers thick. Since astronomers discovered that Callisto possessed an internal ocean, there has been increased interest in studying this icy world. Further, the water is one of the primary resources for life to emerge. If there is water in Callisto, it may also have extraterrestrial life forms. Or not. Callisto's habitability. Although it's not as famous a moon as Titan or Europa, Callisto has water, enough for scientists to set their sights on it. Observation of Callisto's inner ocean do not provide us with much information about it, as several factors could influence its temperature and density. Some scientists speculate that even under the worst conditions, microbial life could thrive within Callisto's inner ocean, an example of which is found here on Earth, and that is halophils. Halophils are microscopic organisms that can survive in environments with high salt concentrations. If these organisms can thrive in places with a lot of salt on Earth, why can't they do the same on Callisto? However, some scientists think Callisto lacks the conditions to host living things because it's too cold. Other moons, such as Europa, obtain heat from the tidal forces exerted by Jupiter, but Callisto orbits Jupiter much farther than Europa. Of the 4 Galilean moons, Callisto is the one that orbits farthest from Jupiter, and it is the only moon that is not in resonance with the others. Jupiter's Galilean moons have a resonance of 1 to 2 to 4, meaning that for every orbit Ganymede completes, Europa completes 2 and Io completes 4. Meanwhile, Callisto is not in resonance with any of the other 3 and is much farther away, so it does not perceive tidal forces like the other 3 moons. The only source of heat from Callisto's ocean is radioactive decay. It is thought this is insufficient to generate the heat living things need, so Callisto's internal ocean would be too cold even for microbial organisms. Although the idea that Callisto's internal ocean is habitable is attractive to the entire scientific community, for now it is not possible to know, and the only way to find out if this satellite has the conditions to host living beings is to send a mission specifically designed to study it in depth. So why aren't we sending space missions to study this fascinating natural satellite? The answer is that yes, we are doing it. But this is NASA's Juno mission that's currently orbiting Jupiter to study the planet and its satellites. But the mission that will answer the questions with more precision will be the JUICE mission that is on its way to Jupiter's moon system. The Jupiter Icy Moons Explorer, or JUICE mission, was launched on April 14, 2023, and is expected to reach Jupiter in July of 2031. This will be the first spacecraft in history to thoroughly study the Galilean moons and search for any trace of life. Of course, sending a spacecraft as far away as Jupiter is not easy, so the JUICE mission will take almost 9 years to reach the Galilean moons. But once it is put into orbit, it will begin a process of exhaustive investigation that will look for all the signs and clues that will help us determine once and for all whether Callisto could be a habitable world or the future home of humanity. Could Callisto be humanity's future home? In 2003, NASA conducted a conceptual study called Human Outer Planets Exploration, HOPE, on future human exploration of the outer solar system. The target chosen to consider this mission was Callisto. This satellite was chosen for different reasons. It is one of the 3 largest moons in the solar system, so it has acceptable gravity for humans. It is orbiting Jupiter, which places it halfway between the inner and the outer planets, and it is far enough away from Jupiter's magnetosphere that it does not receive as much radiation as other satellites closer to Jupiter, such as Europa. NASA's conceptual design proposed a possible surface base at Callisto that would produce fuel for rockets heading to planets farther out in the solar system, such as Uranus and Neptune. The advantages of a base on Callisto include low radiation, due to its distance from Jupiter, and geological stability, since it doesn't have volcanoes like Io. Such a base could facilitate the exploration of Europa or be an ideal location for a Jovian System way station to surface spacecraft going deeper into the outer solar system, using the gravitational assistance of a close flyby of Jupiter after departing from Callisto. Thanks to this idea, in December of 2003, NASA reported that a human-crewed mission to Callisto could be possible in the 2040s. Of course, this project is still beyond the reach of modern technology. Traveling to Callisto is very difficult, both because of the distances and the time it takes us to get there. But if we keep moving forward on the right path, maybe one day we will make it. Why is it so difficult to get to Triton, Neptune's largest moon? Triton is the largest natural satellite of the planet Neptune and the 7th largest moon in the entire solar system. This moon is one of the most important bodies for scientific research, as it is believed that it could have an ocean of liquid water beneath its icy surface. However, even though Triton is such an important satellite, only one spacecraft has visited it in history. Then why haven't more efforts been made to visit this natural satellite? Is it tough to get to Triton? Triton has several unique characteristics not found on any other body in the solar system. Some of them are: it is the largest natural satellite in the solar system with a retrograde orbit, which means it orbits in the opposite direction of Neptune's rotation. Large natural satellites, such as Earth's moon or Jupiter's Galilean satellites, usually form with the planet. Because the accretion disk from which planets and natural satellites form rotate in only one direction, a planet's natural satellites gets orbits that coincide with the planet's rotation. The only way a natural satellite has an orbit contrary to the planet's rotation is if it has been captured by gravity. This can be observed on Jupiter. Jupiter has many natural satellites with retrograde orbits, meaning that many of its moons orbit in the opposite direction of Jupiter's rotation. Jupiter's gravitational pull is so great that when asteroids pass close to it, some can sometimes be trapped by the planet's gravity and remain orbiting it, but in a direction opposite to that of its rotation. Satellites with retrograde orbits have been known for a long time, but it was believed that retrograde orbits can only occur on small satellites. The strange thing about Triton is that it is a massive satellite with a diameter of 2,707 kilometers. It has a size that represents 77.94% of the diameter of Earth's moon, and it is the second largest planetary moon about its planet, only surpassed by the Earth-Moon ratio. Being such a massive and large object, it is impossible for it to have formed together with Neptune and acquired a retrograde orbit during its formation. Therefore, the only explanation for Triton's retrograde orbit is that Neptune's gravity captured it at some point in the solar system's history. A dwarf planet? Currently, the most accepted theory is that Triton was a dwarf planet that orbited the Sun in a region very similar to the one that Pluto has today. Still, at some point in the solar system's formation, Neptune's gravity trapped Triton and began to orbit this planet in the opposite direction to its rotation. This idea is supported not only by its retrograde orbit, but also by studies of Triton's composition, which indicate that the materials of which it is formed closely resemble those of Pluto. Like Pluto's, Triton's crust is 55% nitrogen ice, 35% water ice, and 20% frozen carbon dioxide, better known as dry ice. This composition indicates that in the past, Triton was a dwarf planet larger than Pluto, but it became a moon when it became trapped in Neptune's gravitational field. Astronomers' observations indicate that the gravitational interactions between Neptune and Triton are unstable. This means that Triton is slowly approaching Neptune. Triton is currently much closer to Neptune than Earth's moon, and predictions indicate that within 3.6 billion years, Triton will pass within Neptune's Roche limit. This will result in a collision with Neptune's atmosphere or the breakup of Triton, forming a new ring system similar to the one found around Saturn. First and last visit. Triton was discovered by British astronomer William Lassell on October 10, 1846, just 17 days after the discovery of Neptune. This discovery was made because Triton was very bright and reflected a lot of light. The amount of light that Triton reflects is so significant that with telescopes of that time, it was impossible to detect any other objects around Neptune. For this reason, astronomers initially called it the satellite of Neptune, alluding to the fact that Triton was the only satellite of Neptune. This name remained until the discovery of the second moon, Nereid, in 1949. Since its discovery in 1846, astronomers have only been able to determine some basic orbital properties, such as its retrograde orbit. Still, with telescopes of that time, it was impossible to see more details because it was too far from Earth. The first detailed observations of Triton began almost a century later, when new, larger, and more potent telescopes were invented in the large observatories. With these, it was already possible to differentiate more features of this moon, such as some spots. Observations made from Earth allowed astronomers to determine that Triton is an icy satellite composed of large amounts of ice. However, its size was not known. Astronomers use different methods to determine the size of an object, one of which is based on the amount of sunlight that this body reflects. Triton reflects a lot of sunlight, so it was difficult to estimate its exact limits. For many years, Triton was thought to be the biggest natural satellite in the entire solar system, even larger than Titan or Ganymede. Gerard Kuiper made the first attempt to measure Triton's diameter in 1954, calculating it at 3,800 kilometers. Subsequent measurements by other astronomers came up with values ranging from 2,500 to 6,000 kilometers, i.e. a diameter slightly smaller than the Moon at 3,474.2 kilometers to almost half the diameter of Earth. For a long time, information about Triton's correct diameter and many other of its physical characteristics was kept a mystery. But this changed in the 1980s when the Voyager 2 probe managed to fly very close to this distant satellite in August of 1989. The images captured by the Voyager 2 probe provided essential information that helped scientists define the exact diameter of Triton, which is 2,706 kilometers, once and for all. Since Voyager 2, no other spacecraft has been sent to visit this distant frozen world. However, the information provided by the only mission to visit this moon helped us determine Triton's diameter and revealed secrets of this natural satellite that we would never have imagined. One such discovery is that, despite being a moon, Triton has a light and fragile nitrogen atmosphere and possibly has liquid ocean beneath its icy surface. This has been corroborated thanks to the fact that different geological formations have been observed on the surface of Triton, which suggests that it has internal heat. In addition, cryovolcanism has also been observed. This type of cold volcanism can only be explained if, inside Triton, some type of heating could be expelling materials below its surface to the outside in the form of geysers. The presence of geysers in an icy body can only be due to something heating it inside. Usually this heat can be produced by tidal forces or by a rocky core with materials that radiate a lot of heat like the Earth's core. In the case of Triton, scientists believe it may be due to both factors combined. But if Triton's interior is warmer than the exterior, is there a chance that the ice on the outside will remain liquid? The answer is yes, because Triton's surface indicates a long history of melting. Models of its interior postulate that Triton differs, like Earth, into a solid core, mantle, and crust. Water, the most abundant volatile element in the solar system, makes up Triton's mantle, which envelops a core of rock and metal. But it's thought that there's enough rock in Triton's interior for radioactive decay to keep a liquid ocean beneath the surface to this day, similar to what's thought to exist beneath the surface of Europa and several other icy outer solar system worlds. This makes Triton one of the most distant bodies in the solar system where liquid water could be present. But if liquid water is beneath Triton's surface, could living beings also exist? We'll only be able to discover this when we send a new space exploration probe to study this further. When will we send the next mission to Triton? It's not easy to visit the frontiers of the solar system. The Voyager 2 probe took 12 long years to reach this natural satellite since it departed Earth on August 12, 1977. The reason it took so long is that to reach the farthest corners of the solar system, spacecraft must travel hundreds of thousands, millions of miles into space. The technology for interplanetary flights of 40 years ago is not much different from what we have today. So traveling such great distances is still extremely difficult, especially when the destination is on the planets farther from the Sun. Traveling long distances requires vast amounts of fuel, but space exploration probes don't usually carry much fuel, so that amount limits their acceleration. One way to solve this is to use gravitational assist, a method in which spacecraft accelerate by taking advantage of the gravity of massive bodies such as planets. This maneuver is used for spacecraft to acquire incredible speeds when they pass close to a massive object, such as a planet, the gravity of which accelerates the spacecraft a little. However, this method is problematic because it can only be carried out if the spacecraft encounters a body during its journey. If it encounters nothing during its journey, it will not be able to use this maneuver. For this very reason, the Voyager spacecraft was launched during the 1970s, since at that time a very special planetary alignment occurred that occurs approximately every 175 years. This alignment would allow the spacecraft to take advantage of the gravitational assistance of the four massive planets, Jupiter, Saturn, Uranus, and Neptune, allowing a small space probe with little fuel to visit all the outer planets and gain enough momentum to leave the solar system. This alignment occurred in the 70s and is not expected to happen again until 175 years later. For many years, another space exploration probe was not launched to study Triton since reaching this distant world again would require a new planetary alignment. Without the help of the planetary alignment harness to take the Voyager probes, it would take several decades for a spacecraft to reach a natural satellite as far away as Triton. One solution to this problem is for a spacecraft to depart from Earth with much more fuel than the Voyager probes had, thus acquiring great acceleration. It could reach a speed similar to that reached by the Voyager probes and thus reach Triton in just over a decade. However, the travel time is still longer than 10 years, which means that if a spacecraft were to take off from Earth today for Triton, channel members who are 20 years old would have to wait until they turn 32 to see the spacecraft arrive at its destination. Similarly, subscribers to this channel who are 30 today will be 42 when the spacecraft arrives at Triton. As you can imagine, 12 years is a long time, and that's one of the main reasons we haven't sent a probe to this moon again, because any mission would take more than a decade, even if it used a planetary alignment like the one used in the 1970s. In short, as the title of this video says, it is very difficult to get to Triton. However, it's not impossible. Currently, some proposals are being made to revisit this distant and cold world. Planning a space exploration mission for a world so far away that the travel time exceeds a decade is not easy. After all, it requires enormous planning and orbital calculations. But that has not stopped NASA scientists, and for some time now, new ideas have been proposed to revisit Triton. One of those proposals is Neptune Odyssey, a mission concept for a Triton-centric orbiter as a possible central strategic NASA science mission. If the proposal passes all the filters, this mission will be launched in 2033 and reach the Neptune system in 2049. As you've just heard, even with modern technology, it would take more than a decade to reach Triton. How old will you be in 2049? Let us know in the comments. Two lower-cost mission concepts have also been proposed for the New Frontiers program. The first of these proposals is called the Triton Ocean World Surveyor. This mission would be launched in 2031 and reach Triton in 2047, while the second will be called Nautilus, which would launch in August of 2042 and arrive at Triton in April of 2057. Can you imagine that? 2057. How old will you be by then? Let's hope that you're still a fan of our videos, no matter how old you are. Now, we would like to know your opinion. Tell us, when do you think the next mission to Triton will arrive? Let us know your opinion in the comments.